In this video, we are going to be adding inductors in series and parallel configurations. Feel free to pause the video or replay parts as needed such that you are understanding the material to your fullest ability. If you are already familiar with the rules for adding resistors, you are already a master at adding inductors because the rules are the same. If you are not familiar, do not worry. We are here to help. The best way to tackle a circuit such as this one is to simplify it down first and then proceed with your mathematical evaluations. Here we see a circuit that has three inductors in parallel. Inductors are denoted by the symbol you see here on the right. It looks like a spring attached to the wiring. We are able to add these inductors together and replace them with one equivalent inductor to represent our circuit more simply. To do this, we implement the following formula. As we can see, our equivalent inductance is equal to the inverse of the inverses of our inductances added together. That is a lot to think about, so let us use some numbers to better illustrate what we are talking about. So if we want to find the equivalent inductance for this figure, we would add 1/2, 1/3, and 1/4 together, and then take the inverse of that total sum, leaving us with an equivalent inductance of 12/13, or approximately 0.923, and a circuit that looks like this. Now we are easily able to assess this circuit. You may have taken note that this circuit is not closed. That was done intentionally for the purpose of this example. This circuit is now able to be attached to any other circuit or battery. Luckily for us, adding inductors in series is far easier. You just add them together. So for this circuit, since our inductors are in series, our equivalent inductance would be the sum of our inductances, 9. Therefore, our simplified circuit would look like this. The one inductor shown here is equivalent to the 3 inductors that were there before. Our circuit still works just the same.